Thank you, Tim. I'm Yoshiki Ohshima, and I'm calling in from Los Angeles. I live here for 23 years now. And yeah, today I am going to show what our company has been doing. And it's not written in Smalltalk, but many ideas many ideas from Smalltalk are used in our products and basically architecture and stuff. So I'd like to introduce that big picture also. And I am going to use our own shared collaborative application. And I'm going to send a link to join it. You can open it in a web browser. But if you are on a mobile device, or like if you don't have a decent computer right now, or you are like too drunk already and just want to watch and enjoy, yeah, don't bother joining. You are not gonna miss much. But if you want to experience what it's like, yeah, please join in. But so not the above link, this new link here. And if you open the link, preferably Google Chrome, you will see a little dialogue that shows the field to enter your name. So enter your name and press the enter button. Yeah, you can enter it. Oh, and of course I'm going to share it. Sorry, I'm going to share my screen. Of course, that's the important thing to do. This one. Yeah, so you can just watch and enjoy the shared screen here. But if you join in, 11 people joined in, 12, you can do stuff. And yeah, this is basically if you drag the graph paper background, you can change your viewport. But right now I'm using a special presentation mode. So as soon as I move, your view will be snapped to my view. So, oh yeah, so and if you move a window, that's visible to everybody. So yeah, just you don't mess things up too much. Yeah, you can type stuff in, for example, but don't do too much. And this is really entirely collaborative. So anyway, so I am going to talk about myself a little bit. So I am, Yoshiki Ohshima, and I was just a student at the Tokyo Institute of Technology, but I happened to do a student volunteer at Uppsala 97. And that's where I met with people from Alan Kay's group up at Disney. So I started playing with Smalltalk. So you are seeing this, right now? So yeah, you can do that too. And so that's how I got involved in Squeak. And oh yeah, so scrolling is also shared. So yeah, I'm going to scroll it. So please don't. So what I did was to port the Squeak VM to a PDA called Zaus. And 20 years ago, Japanese used to make the best electronics in the world. And their stuff was pretty good. And by doing so, Disney folks, yeah, don't scroll. Please don't scroll. Sit back and relax a little bit. You can play with this later. So the Disney wanted to do a theme park guide. So I'm going to actually talk about that. You can look up the paper here. This is 7 years before iPhone came out, but there was stuff called PDA. And Disney folks thought that in the future, people would be carrying around those little devices, and people would want to look at restaurant menus and like get the remote fast pass, kill time during the waiting for a ride and stuff. So I actually steal one unit from Disney, but they started experimenting this idea of portable electronic device in the theme park. And because Squeak's capability of dealing with multimedia content, and this PDA was sort of the state-of-art device back then. So they decided to use this device and Squeak as a platform to make stuff. So with John Maloney of the Squeak team and Scratch fame, and I are two programmers embedded in dozens of designers in the team. So we made basically guide application. We took 100 units to Animal Kingdom in Florida. And my main job was to take care of the like more low-level part, like the DM and the software. So every night I disassembled those 100 units and put the new content and stuff. In the morning, we solicited the visitors and asked them if they want to participate in the test. And so our cast members explained how to use the device. And actually, this is Alan Kay. He flew to Florida from Los Angeles and tried it. And back then, yeah, you know, if you go to a theme park, you see a cast member like this whose job is to take a picture and sell it. But this device had a camera. It's like 320 pixel by 240 pixel camera. But as you know, the best camera is the camera you have with you. So those families started taking pictures like this, and he was really worried about his job. And he was right. But one thing I want to mention is that, as I said, there were two programmers, but 1,000 of designers. So programmers should not have been the bottleneck to make progress. So what John Maloney did was to make a little authoring tool that designers can use. So this was basically the card-based database, and you as a designer can do a nice Disney quality artwork, and you can import those artwork in the stack of cards, and you can put buttons on those. You as a designer, no program needed. And then once you run it, is that a question or? Okay, so I'm not looking at the Zoom window right now. So if you have a question, yeah, ask me instead of typing in. I'm not looking at the chat. So the designers can make content. So in short, John and I didn't make a theme park guide app. We made an authoring tool to make a theme park guide apps. And designers used to make it. So that's how we managed to make this nice experience with relatively short time. And yeah, so that's sort of what I did, or my initial encounter with Smalltalk, so to speak. So I want to switch topic a little bit and talk about the history part of what the Croquet company is trying to push forward. So, of course, we need to start from Alan Kay, and as everybody knows, he in 1968 he met with Seymour Papert and saw what they were doing, and thought that in the future, even children will carry around little devices like this.
Yes.
And then they will, instead of consuming.
It's in the drawer.
I didn't see it.
Okay.
Sorry, someone needs to mute themselves.
Look again, I'll be there in a minute.
Instead of consuming medium, they will be making stuff on those devices. And you may not
Towards
notice
the front
this,
on the left side.
If you look at those two screens, they are actually looking at the same thing. And this is, they are playing the Space War game together one-on-one. And instead of playing the game somebody made, they made this game and they are playing it. So that's what the Alan envisioned. And yeah, collaboration was already here in his idea. This is him. This is my wife, and this was my baby back then. And but Alan got that idea, collaboration idea, from somebody else, and the main source of that idea was Douglas Engelbart. And probably of course, you have seen the video of this, and Engelbart's group showed like very future-looking demo in 1968. You can watch the video now. But one thing that's very important to notice here is that they are using their collaboration application even when they are in the same room. And that's because Engelbart was interested in augmenting people's intellect. And he thought that collaboration with computers' help is the way to do. So even they are in the same room, they use computers to augment their intellect. And nowadays, people think we are collaborating by using computer technology, but like Zoom does not, you wouldn't use Zoom when you are in the same room with somebody else, because Zoom does not augment your intellect. But it's just a glorified telephone. But if your computer is actual help, you would use it. And oh yeah, by the way, this collaborative application is called Greenlight. And I wanted Greenlight to be something like that. And this is Engelbart and this is my wife. But Engelbart was founded by the upper IPTO, and the main funders were J.C.R. Licklider and Bob Taylor. And so they are also interested in this idea. So in 1960, Licklider wrote a paper titled Man-Computer Symbiosis. And basically computer and human will help each other to think better. And the later paper co-authored by Licklider and Taylor had this image. And one person is presenting the bridge, but other people can check the material strength and actual, or write a simulation and try it. And so this was the picture actually influenced by what Engelbart was doing. This idea goes way back. And you may know this, but this one is called Oliver, and in the same paper, but your computer will know who is prestigious in your eyes and the buffer you from a demanding world. Actually, so I'm using this storyline a few times now, but what this means is very different in last few months because of ChatGPT and stuff. So, but of course, the science fictions existed way before 1968, but for the realistic way of thinking about it, of course, this idea of the computer agent also goes back long. Yeah, so that's sort of the background. So the key takeaway is that we want to have a collaborative environment that augment people's intellect. So you would use it even when you are in the same room. So that's what we are trying to do in some ways. And sort of at the same time, the Croquet's CTO and the founder, David Smith, he's been doing the 3D collaborative space for a long time, because 30 years. And if you, I'm not gonna really play this, but if you click on the play button, you can actually play, and I can skip forward. So this was really an early prototype he made, and yeah, he was thinking about this for a long time. And as you know, David and Alan, Andreas, and David Reed did Croquet in Smalltalk, quick Smalltalk. And yeah, I'm not gonna play this now. You can watch the video later. But so Croquet was tried in 2003, and there's no end date here yet because this strand of Croquet is still going. And the Ron Teitelbaum as a company who is still using this and getting customers. But we are doing it a separate thing now. So based on those ideas from very late 2017, we started a company called Croquet again. And we decided to use JavaScript because we don't want people to install things. And browsers are everywhere. So let's do it in browsers. And the choice was JavaScript. But so that's what we started doing it. And we are calling the network infrastructure part an OS. And the operating system, calling like browser app, even with a library, an OS may be a little bit off, but Alan Kay once said that an OS is a software platform that manages space and time, like memory space and CPU time. And yeah, Croquet does manage space and time. So that's how we decided that it's okay to call Croquet network infrastructure as an OS. And the difference, Croquet technology is somewhat different from a typical way of doing network collaboration. And the typical network collaboration works in this way. So basically you launch a high performance server, you have to pay for it. And when a client does something, you send an event to the server, and server computes the state of the new world. And then this thick line means the server sends a lot of data to everybody, and then everybody displays it. That's how typical client server model works. But Croquet doesn't do it. Croquet, instead of has a very little server we call reflectors on the internet. And when the user interact with the shared world, an event is sent. I should actually do this. Event is sent. So now user B interact, event is sent to the reflector. Reflector just append the timestamp. It doesn't compute, but send the events back to all participants. And the Croquet's technology ensures that starting from the same state and receiving the same event, they go into the bit identical state. So then compute happens on the client side. And then the views stuff on screen are updated based on the state that's already available on the local computer. So you don't have to send big data from the server to client. And so that's how Croquet works. And the Vanessa Freudenberg architected this JavaScript version of infrastructure, and Alan Lanza helped a lot. So this concept is very simple, but their engineering effort is immense. But because they are such great engineers, they managed to make a very robust infrastructure. And that's like this green light is built on top of it. And the 3D stuff and other applications I'm going to show are all built on top of this infrastructure. And by the way, this looks like an animated GIF where you can stop and run and it's synchronized. This is also a Croquet app. Oh yeah, one thing Yeah, no, I'm gonna show it later. So the Croquet OS part is open source and you can actually start developing stuff. So how you write a Croquet application. So there are a few rules to follow, but otherwise it's kind of very straightforward JavaScript. And the main thing is the model view separation. So your model, sort of the logical part of your application, has to be bit identical, deterministic, and serializable. So that's what we call model. And then view can use any browser features, but it's not part of the logical part of the application state. And so this is basically model. Model side code can be like anything. Rotate by, for example, here says that basically the logical objects rotation will be changed by a little bit. And the Croquet programming model has the explicit notion of time. So if you say future 100, meaning invoke something in 100 milliseconds in the future. So this line says, do this in turn, basically rotate the object a little bit. But 100 milliseconds later, invoke the same thing again. So this is basically the loop or time-based recursion. So if you run this program, your object will rotate, keep rotating. And at the same time, on the view side, you can use any JavaScript features. In this case, it's using the 3JS, that's a 3D graphics library. So you can instantiate the geometry, material, and make a mesh. And then if this view side code is coupled with the model side code, basically this is a sphere. Sphere, you cannot see the rotation, but this object will start rotating on your screen and everybody's screen at basically 0.1 radian or 1 radian per second rate. And it's fully synchronized without sending states. The reflector synthesizes time events, so all clients follow the logical time and they show the exact same thing. And the one thing, let's try it. So I'm going to launch application here. This is just a URL. And if I do this, and so if you move the red sphere, now you are invited to move around the stuff. You hear the sound. So the black bar is moving from left to right. And when the black thing hits the X coordinate of the red thing, it plays a sound. And the Y coordinate is a pitch. So lower thing goes lower sound and higher position can go higher. And the one thing I want you to try is that I popped out the QR code and you can scan it with your phone. I am doing it. And I am in the exact same state. And I am now moving this ball. And yeah, if you try it, just check out how well it's synchronized. It's like no delay, no latency. And so this is really a very simple application, but you can write this kind of stuff very easily now. And because I'm gonna talk, I'm gonna close this, sorry. Oh yeah, one thing I forgot to do is that, so I can resize this, right? But Tim, can you move the sticky note by dragging the tape up? So what's happening is that I am resizing and Tim is moving, and we can do this at the same time. And this may sound trivial, But if you try this in Miro and Google Jamboard and other collaborative software, you cannot do this actually. If you move something, release the mouse, and 1 second later, everybody's screen gets updated. And that's not fun. We want it to be more direct and real time. So our technology is pretty interesting. And I mentioned JavaScript, but it doesn't have to be JavaScript. So I wrote a little Smalltalk to JavaScript transpiler. So I hit Command S in the right-hand side to evaluate this code, and I hit Command S below to instantiate a morph, and I can click it, and it rotates and it grows because my on-click handler here says change the width by 10 CSS pixels and change the angle a little bit. So Tim, if you keep clicking on it, yeah, I'm not clicking, Tim is clicking, and it's doing it. But maybe I don't want it to grow, I want it to shrink. So I changed plus to minus and accept it. Yeah, keep clicking on it, now it's shrinking. And I want it to go the other way, so now it goes the other way. So this is really like Smalltalk. Well, it is Smalltalk, but in browser and dealing with CSS and DOM objects. So the base language or the browser uses is JavaScript, but you can have any language on top of it. And just the last part of Greenlight, I think. So you can, this is a PDF document, we can scroll. But because it's the web technology, this is a regular Google Docs, and you can actually type in stuff here. And what you can do is like, I can highlight, I can point a part in the document. Hey, this is my keywords. And you can take notes and stuff. So if you want to write a paper with your colleagues, and if you try to do it over Zoom, you send a link to the Google Docs, and maybe you send a link to like some papers, but the receiving side, there will be many windows, and where did my Google Docs go? Where did my other document go? And you end up with fishing for those windows all the time. But in Greenlight, I have a fairly good confidence that you are seeing the document on the left and Google Docs on the right. And I'm pointing, you can see I am pointing at the keywords part, for example. So this is kind of a fun way to collaborate. So that's one of the applications, but actually the main thing I want to talk about is a 3D application. Oops. So I'm going to switch the gear here. And let's try this one, I think. So I am going to, so now if your computer isn't, now your computer will be tested. And you may think that your computer is fast, but if you don't clean the dust inside, your fan may often be may not be working well. And then your computer gets hot and CPU may be throttled. And now it's a time to know if you should clean your computer. But anyway, so if you drag the little dot at the bottom center, you can move around. I'm gonna do this. So wow, now 18 people inside. But so this is a 3D environment. And as you know, you didn't install your program. You didn't have to, this is just a web page. And actually you can open this on your cell phone too, if you scan the QR code, and it's very, very synchronized. But yeah, so, but now release the joystick, I am going to do a guided tour, and I want you to look at what I am looking at. So I take everybody here, and I am in this big room. And now you notice that there's a drone flying. Yeah, release your joystick. I'm going to do guided tour. And this drone is running this program here. And the setup says, like, pointer down toggle, and toggle method changes the circling property. So if I click on it, it stops. Click on it, it moves. But besides that, there's that rotation thing happening. So this one says in 20 milliseconds in the future, execute the same step method. But in the meantime, you rotate the object. Yeah, don't edit just yet. Rotate a little bit, forward a little bit. So it's like the logo program. That's why it was going in circle. But this is sort of no code environment. So if I control click and open sort of the Smalltalk like inspector, you get this property sheet. And there's a button called, say, a button that says duplicate. I duplicate, 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 duplicate. So I created many of the clones and I deleted the first one. They are all following the same program because they are clones, and setup says start circling. But what I can do is to edit, for example, forward by from 0.03 to minus 0.03. And I am going to hit Command S here, and they go the other way. And the exact same thing happens on your computer. And I can maybe change that back to, I don't know, 0.01 or something. Oop. And it's easier to see. So save and they move. So this is a real-time collaborative environment where you can write programs in the world. So if you are working with a designer and say, you want to, I'm gonna gather people here. You want to say, yeah, how about this parameter? And how about that parameter? You can get instant feedback from designers and players, and you can change it. Oftentimes, if you are making collaborative application, you may have to update the server, you may have to build the application, new version of application and install it to everybody's device, and you get back to the same state and then test. But this is like Smalltalk, like collaborative. So you just change the code on the fly and you can see what happens. And I am still taking so release your joystick. I'm going to take everybody. Somebody is insisting on moving around. But like, so this garage door I opened, for example, this is another behavior attached. But while this was fun, I was showing this to a former colleague of ours, and he said that no, but professional programmers are not going to use a clunky, I'm going to stop it, clunky gray text editor in the world. They have their favorite text editor already, and they are not going to use this. And so I thought, oh, he has a point. So I thought I can make it work. So here I opened the garage door, and there's some engineers who had too much free time. They set up physics simulation. And again, if you scan the QR code here and look at this from your phone, the objects are really totally synchronized. Even this is running the actual physics simulation. And if a cube stops somewhere, like I can click on it. Oh, I missed it. If you find a cube that stopped, you can click on it and it's gonna jump. But let's say I want to write a bigger program. So I'm going to share my text editor here. So, oh, this isn't really great. Actually, sorry. And I'm going to make this narrow. So you are looking on the right. This is a very nice text editor called Emacs, and that's running on my computer here. And I have a program called cascade.js that's running this simulation. And this one has the model and view. The model side says that, model side is just doing the physics, and this is the model side. So when the new object is asked to be in the world, and if the shape is a ball shape, it creates the ball-shaped collider description. If it's cuboid, it creates the cuboid collider description. Those are all logical side of it. And here's like a jolt method. That's what, you can tap on the cube and you can give it a jolt. And so, like that. So that's written here. But on the pawn side, it creates 3JS objects. And that's why we can see the logical object on your screen. And if it's a ball, it creates a sphere geometry. If it's cuboid, it creates box geometry and stuff. And the spray here states that, basically every 500 milliseconds, it calls the spray method again. And inside, there's a math random, and the dice variable here gets a random value. And based on the dice value, it either creates the Earth. Once in 100, you get to see Earth tumbling in the factory. But or if it's like 40% of chance, it's a cuboid or a ball. So that's how it works. But let's say you are writing this program with your designer. I should say connect here. And the designer says that, oh no, I don't want to have those random colors. I want to have the red color thing. And I say, oh, then I can return a color like reddish color, and I'm going to save the file onto my local disk. And there's a little web server running on my local computer, and that injects the changed code into the world. So now we are seeing the all red objects, except the sometimes shows up. But then designer sees it and says that, no, I actually want to have green objects. Then I can change it to green. And now it's creating all green objects. And then the designer may say, oh no, actually random color is just fine. So I can get back to it. And this is a little parameter editing. And it's kind of nice. But you can write a bigger program. So this is like 500 lines of code. But let's say we want to add a different shape while it's running. So I say, why I went into the model side and say, if the shape asked is a cylinder shape, let's create a cylinder-shaped collider description. And I saved it, but nothing happens because nobody is asking to make a cylinder. And I go into the view side and say, or when a cylinder shape is asked, let's make the cylinder geometry of 3JS. And I saved it, nothing happens yet. But because nobody's still asking to make a cylinder. But here, I go into the spray part of it. So dice, what is it? Dice was the random color, right? But instead of just making cuboid, let's say, no, instead of just either cuboid or ball, I create a cylinder type here. If it's the random number is between 40% and 70%, and I save it. And now we are going to see the cylinders in the world. So this is really live programming environment like Smalltalk, collaborative. and 3D, and everybody can do it at the same time. So that's what we have. I got back to what happened.
That's awesome. That's really cool.
I might have broken the program, but anyway, so that's what we have. Yeah, so we can have many other things. So oh yeah, what I want to show here, let me take everybody here again. So nowadays you can, with your cell phone, you can scan your object meaning like stuff in your room and make a 3D model. So I am going to drop a model I scanned from my Finder window into this running window. Or yeah, so now I'm gonna gather everybody. So this is my stuffed avocado. And you can just make this kind of stuff easily by your phone. And this one doesn't have any behavior, but I can open the property sheet of this guy and looking at this list of behaviors, there are some things you can choose. And one of those is circle. So I chose circle and the apply. And now I applied detachable, attachable behavior to the object, and it follows the description. But I don't want to have it. I removed it, and instead I add spin, for example, apply. Now I can drag and move, spin. And you can edit code inward as well as outside. So you can drop in and you can construct your world very easily this way. So that's environment we have. And actually you can save the object you created into a file and you use it. So if you remember this, back then people used to talk about a thing called NFT, and that's like the digital artifact. You can claim the uniqueness and authenticity and put price. And we didn't jump onto the NFT bandwagon, sorry. But the idea, some idea of digital artifact where you can ensure the authenticity is good. So you can actually create an object, save it to your disk or network and say, this is yours. So if I saved my avocado object with spin, that's my object, for example. You can do that kind of stuff too. But one little thing I want to show, or actually two more things. I'm going to switch the room here. And
there are a couple of questions, Yoshiki. Shall I wait until the end and then we can ask them?
Yeah, okay. Okay, so I
finish your demo and then yeah, we'll get the questions at the end.
Yeah, maybe I have okay. This is gonna be short, I think. So I'm gonna take everybody, well, maybe not. I'm gonna take everybody here. So this world terrain model is just another common 3D object. So you can create your own. And this, if you go to this area, there's an earth you can spin around. So factory, I should have shown a few more things, but that's okay. So the car is going around. And the car is going around because it has a similar logic to say that, forward by and rotate by based on the angle and speed. And there's a thing says with control, with the keyboard, you can change the direction. And here, I can change the spin of the earth because the earth has this behavior to say, let's say spin it. But here, one place that says that it basically announces the change of the angle. Basically, it says that, oh, I'm changed. And it publishes an event to this world. So that may mean that if I say, oh, I want to listen to that event the Earth is going to send, and if I have the method that changes the angle, oh, yeah, don't edit it yet, based on the incoming value, so I accept it, and now I am going to, yeah, so I gather people here. I spin the Earth and the car goes, I can now drive the car by spinning the Earth. Oh, but this is spinning too fast and very hard to edit. And Alan used to do this demo. But in the first time in their life, a child will learn that division is useful for something else other than dividing 20 oranges by 5 kids. Division can be used for scaling. So I'm going to accept this, and I'm going to spin the Earth. Oh, now it's much easier to drive. So again, if you're making a game, this kind of parameter tweaking is takes so much time. But in this world, you can try this quickly and with your colleagues. And there are like bunch of other demos, but yeah, I guess I am going to talk about the history part a little bit. I wrote up a few things, a few blog entries. Oh, it's not linked from here. But so the one of the things I showed was to have object extension mechanism. I showed that you can attach and detach behavior cleanly, and they compose nicely and stuff. And I want to talk about where did that idea come from. So if you have heard of traits, and if you look at the Scala's manual, it says Scala has traits. And if you look at Rust's manual, it says Rust has traits. And if you look at PHP's manual, PHP has traits. And this is something you may not know anymore, but this language had traits too. And in this language, you can actually write like R cubed in this way. And this is what's a language called Fortress. And so traits was the idea that's used in many other languages. But in this round of traits, there was a different traits before. But this idea of traits came from this paper, by Nathaniel. And this was done in Greek Smalltalk, of course. That's a composable behavior idea. And the Nathaniel was actually an intern at Disney, while I was also an intern at Disney. And I was watching his work and admiring his genius. And Nathaniel was doing this under Alan's and Andreas' suggestions and stuff. Well, Alan had a little bit different things in his mind when he was interacting with Nathaniel. So back then, we were working on eToys, Squeak eToys, that was a drag and drop blocks-based programming system. And what Alan wanted was that, this was also the car goes circle and car goes like square. Like this one, you have to click on this 4 times to make a square. But so basically this behavior square uses those fundamental methods and provides new feature. And this circle method uses fundamental features and provide a new method. So this set of methods like this is like a trait. And in Squeak eToys, you see it like this. This blue car has circle and square, and it's called scripts. So what Alan wanted was that why can I just drag this panel and drop that onto the red car, and then red car gets the behavior. And we didn't have this, and we didn't implement it. But that idea separated from sort of Nathaniel's very nice and partly theoretical work of composing behaviors. This really visual and direct way of composing behaviors left me a strong impression. So when I was designing Croquet Microverse, a 3D thing, I really wanted to do this. So that's how we have the composable behavior in Croquet Microverse. And this one is another big inspiration. And this one is Goldstein and the Bob Law work called PIE, P-I-E. And they had composable behavior idea in terms of basically AI frame ideas, inspired by frame ideas. So I was also inspired by PI's way of composing behavior. So composable behavior in Microverse was influenced by like those ideas. And another thing is to write the entire framework by ourselves. And of course, I didn't, when I was at college, Java AWT came out, and I didn't know any better. So I thought like it was, we all know, it was such a big deal and very popular. I thought Java AWT is a state-of-art way of making graphical user interface. And but a few years later, I started learning stuff, and that was really bad. In Java AWT 1.0, you have to subclass like the component object and put the behavior and visual. So you cannot have composable visual and behavior separate and compose them. You have to subclass one thing and put everything in it. And the second version of AWT, they started putting the listeners and stuff. But idea was old. So I was learning those. And of course, the MVC of Smalltalk directly influenced the model view separation Croquet has. But one big idea, however, is that when I was looking at what John did in Morphic, big idea there was that you can actually make a framework by yourself, and you can make good one if you know what to do. So like learning that idea was great. So still making the graphical user interface framework isn't that easy, but knowing what to do and knowing that you can do, that gave me the good confidence, or sort of something you might learn from apprenticeship. And I got a very lucky time to learn from the best. So that's what happened. And some ideas from the AppKit, like the fast responder is in Microverse. So those are great ideas, I think. And we have all of those stuff in the Microverse framework. And probably one more thing I want to talk about, and this also has changed in the last few months. So I lay out like pictures, and this top row shows how your computer looks, basically the physical appearance of the computer. And the bottom row here is an analogy or what it compares to. So basically this bottom row says what it is like. So when this is IBM like 704, like I never seen, but I'm going to see it today, I think, at Computer History Museum. So mainframes are like this. But what Engelbart said was that it's like a railroad. You have to wait you have to coordinate with other users. You really cannot decide where to go by yourself. You cannot decide when to go. And so it's like railroad. But what Engelbart wanted to have was like, by doing a little bit of training, your small group can decide where to go, when to go, and like how to go by yourself. So he said that what they are making was like a car instead of railroad. And the Rick Ryder and Bob Taylor, they were onto something, and they did have really good idea of that computer as a communication device. But they were basically experimental psychologists. So in some ways, they are this was PDP-1. They were thinking that computers were like devices and equipments to do their experiments. But what Alan Kay was great, in my view, was that besides thinking about the form factor of the device, he states that no, the computer is like a book, a medium where you can convey ideas to other people, but not only being a book, it's a dynamic book. So you can change the way you communicate in the book itself by writing stuff into it. So that's what he called a dynamic book. So it's a medium to convey ideas. So that's the like big idea. Then I used to talk about that, we don't know the next generation's form factor, but we kind of know in some ways. It's gonna be like your wall, it's gonna be a computer, like your eyeglasses will be your computer, and your whatever, like a little thing in your room, it's gonna be a computer. So basically the computers will be invisible and everywhere. The form factor is gonna be like that, that's for sure. But of course they are going to be like this Oliver agent. They are computer agent that can do stuff. But one thing we don't have in my mind is that we don't know what it's gonna be like. And it's not easy to say because there is no single correct answer. You can have many different answers here. And one answer may be that it's gonna be like your slave, or it's gonna be like your servant. But it could be like your friend, it could be your coworker, or it could be like really something else we don't know yet. So coming up with the analogy here in my mind is very important now. And combined with the idea that computer should be something that augment your thinking, intellect, that's gonna be very interesting. So basically that concludes my talk. And thank you very much. And I should look at the comments now.
What a way to end. We're all sitting there thinking, gosh, what is it going to look like? Is it God? Is it your imagination? Wow.
Yeah. Oh yeah, so if your brother, I'm reading the comment by George, joking. So your computer may not be ready for running this collaborative thing and many other applications running and 3D thing at the same time. But as I said, you can first clean out the dust in your computer, and that may help or get a better computer. And does it work in Quest? Yes, it does. You can just open the like croquet.io from your Quest and press the enter VR button. You can try it. It's not perfect, but it does work, and it's open source. Oh yeah, one thing I forgot to mention is that Croquet Microverse is also open source. You can try it in any way. The computer spec, mine is M2 Mac, like 1 year old, and I'm running it from my laptop, not any powerful thing. And it runs perfectly.
I've got a non-M MacBook Pro, so a couple of years old, and it seems to be working all right.
Yeah, it should be fine. How did you get, so editor, so there's a like 50-line JavaScript server I'm running on my local computer, and that watches the file change. Yeah, you can, so besides, you can, yeah, try scanning the QR code here and scroll, that's kind of fun. So the watch server running on my local computer watches the file change, and via WebSocket, like Webpack does, it injects the changed code. So another important idea is that code is data. It has to be shared. So code is data. That data is propagated to all participants and evaluated and run. So that's how it works. And if you want to roll back change, so that's something you can write by yourself. The Croquet model itself doesn't support it directly. You can remember all like last few events and go back, or you can pick up a different snapshot in theory and go back to the snapshot. And also, if you remember the music box, I deleted music box example, you can drag the red ball really quickly, and its view side update is instant. You don't have to wait for the server round trip to update your view. Because I know that balls don't collide each other, there is no interaction involved. So I, as an application designer of that music box application, I can decide to speculatively update my view first. So that kind of stuff is possible. And what happens when you lose your network connection? Yeah, so the system takes a snapshot, another Smalltalk influenced idea. The system takes a snapshot now and then, and when you lose a connection and you rejoin, the client looks for the latest snapshot and all events after the snapshot, so it can catch up to the latest state rather quickly.
It didn't seem. I noticed on my phone, because my phone had sort of shut down when you were gathering people. If my phone was off, it didn't. I thought it might sort of run forward and stand me in front of the earth. It didn't seem to do that. I wasn't sure quite what the deal was with that.
So the gather thing, when the guided tour is going on and you join afterwards, so it's an application designer's choice, and I didn't choose them to be in the guided tour. You can leave the guided tour, and if you join in, you are not in the guided tour.
I see. So it's not sort of an event that you can. Okay, I get you.
Right. Yeah, that's something application designer can decide. Croquet has an idea. Portals. Yeah, we can show it. Let me go through the comments first. Yeah, I forgot to show it. Portals is an interesting idea, definitely. Conversational. Yeah.
Not sure.
Okay. Yeah, thank you. Sorry, big. Well, so the large data, yeah, so that's a good question. And the one thing we can do is to run a headless client on the cloud. And that one accesses the database from its view, like headless view. And the database access may be done by one client. And that one injects the distilled data into the reflector network, and client see it. in fact, I didn't show it, but one of the demos we have is a flight tracker, and we can query the Open Sky website to get like thousands of current commercial flights over landmass, and we enter them. And only one client does the network access, and the results are propagated in the Croquet network. And when watching the physics demo, via Zoom, possibly. I don't think it was a snapshot. Possibly the Zoom thing, or when I inject code, that's still several tens of kilobytes of data that might have. I'm not sure. And if there aren't more questions in the chat, yeah, I want to show the portal. Let me go to here. And oh, yeah, nobody opened it, I guess. Where am I? Oh, this is, yeah, okay. So I'm confused a little bit. So here, and 9 people. So I am gathering people now, I think. Oh no, somebody, oh, interesting. I cannot do it anymore. Really, somebody, okay, let me. Reload. I am going to gather people. Yeah, so I'm going to the far side of the open area. So the portal is like this. So let me gather people here. So it looks like nothing, but if I click on the door here, oh, that, oh, interesting. That does not work right away, but I can go to a separate world. Oh yeah, I forgot to change it, I guess. Yeah. We are getting into a separate world. In fact, yeah, so this one, oh yeah, first thing, the Bitcoin tracker here, that's one of the real-time data thing. So this is fetching the actual data of Bitcoin and showing it. And the problem with showing like stuff like Bitcoin is that people forget that we are talking about the 3D shared space. People start talking about Bitcoin. But now it's okay, I think. But the portal, let me do the gather. So if I click here, it allocates a new iframe. And so we are looking through the door into a separate world. And notice the forklift, actually isn't moving because I stopped it. This is the exact same world we are experimenting with. But what's going on? Oh, this is only for me. Is that because this is purely web technology, and we can allocate a separate iframe behind the iframe that's running the gallery world, and open the factory world in that iframe. So we just punch a hole in the front iframe, so to speak, or the canvas. Just make the part of the canvas transparent, and you can see through the front iframe and see the iframe behind. So you can use your joystick and move into the separate but connected world, which I did. And you come in, and you can open the portal that goes back by clicking on here. But so that's what portal works, and that's how portal works. And let's see if you.
So I've got a little bit of a further question on that. So when we go through a portal from one world into another world, do we go from one tea time clock to another distinct tea time clock? What distinguishes different worlds, for example?
Yes, so they are separate Croquet sessions, and they are on different timelines. So yeah, they don't share the same timeline, basically.
Thank you.
So that's an interesting question, and we don't have the full answer. If you really want to have thousands of people in connected worlds, and what can we do is a little bit of question. And so yeah, I'm going to answer another question. Is it when? Oh yeah, so the two more questions. Pauses in simulation. Okay, so that may be, I don't know. There are many reasons. But maybe because there are too many people, maybe your geographic location isn't close enough to London, or doesn't have a good connection to, not London, actually Frankfurt, Germany. That's where this reflector is. And how does the technique of, so the OT and CRDT, we can mix it together. So the text field here has a little bit of operational transformation going. You still have to transform events sometimes. So if I'm selecting like this, if you are watching the text field I'm pointing at, I am selecting a few characters, and now I'm going to delete it, hit the delete button. But at the same time, somebody may be inserting the character, so double quote in the same time. So I still want to have my action to be intentional preserving. I don't want to delete your character. So on the client side, we sort of transform those events, delete and insert, and try to do the right thing. So you can implement like OT on top of Croquet. But one very good thing about this is that because the order of events are totally guaranteed for all clients, there are many cases we don't have to consider. So let's say you have insert, delete, like select from user A, and the insert, delete, select from user B, and you want to transform events. You get a 3x3 matrix and 9 cases, and there are many weird things can happen. But by guaranteeing the order of events, the matrix becomes much simpler, and even I can make that work. So, and the CRDT can be laid on top of this, but that's an interesting idea. And another thing, we don't fully have the answer. So I talked about this like network first by default. And I was one time trying to make a facetious comment about the local first versus network first. But local first definitely has great applications and great use, and it's something you want sometimes. But it doesn't, you cannot do like physics simulation in the local first situation. But network first approach does not let you edit text offline. So we are looking for the best of all worlds by marrying the network first and local first. And people should think about this. Yeah, any more questions? Well, there are 40 people.
I have a question about the Croquet, the 3D thing. How much physics is modeled there. So it seems to be that there's no collision detection for walls or when you walk into other people or stuff like that.
So yeah, we don't do avatar to avatar collision on purpose. We could actually, and as I was showing the physics engine, oh, not here, the other place. So this small thing, this is
yeah. Oh yeah. There was collision detection. Oh yeah.
Full
yes.
physics engine, but we just don't use it for avatars and the other objects. You get to choose what to do.
Okay. This is a good point for another or similar question. How do you model interaction? So by now you have objects and the objects have behavior. So, and you can edit this and all live and wonderful. But how do you, how do objects interact? So how would I as an avatar interact with your avatar? Could I punch you? Could I throw you around? Or could you, I don't know, whatever, break my leg or something? How would you? So in computer terms, I don't know, would my avatar scan the world all the time for options for action, or would all the avatars do that all the time? So that would be incomputable, I think. This is intractable. But how could you do that efficiently?
Yeah, so avatar, like you might expect from a small talker like me, the avatar in the world is just the same kind of the object. This forklift here, where's my cursor? The forklift here and my avatar are just the same kind of objects, except my avatar has extra behavior attached. I'm showing the sort of part of code in my Emacs editor here. And this one describes what to do when, let's say, like I do pointer down and pointer move and stuff. So this
but that's all your behavior, right? I mean, that's my own behavior, your capabilities. But how do you react? For example, this transport thing just ran through you. So how would you react to that? Like it's coming again.
What?
Here it's coming again. How would you crash? So poof, legs off.
Sorry, Mr. How do I move, you said?
So now how do you detect that there is maybe an interaction between two of these objects? Or is
also at any logical time step and when you are updating the model.
Okay, so it's a model thing. So
let me model part of the application.
Yeah.
You would run the physics engine.
Yeah, okay.
And determines one object collides with another, right. And they move their positions separately.
Okay, perfect. Yeah.
I mean, is there some concept of like global traits or something that you a model entering the world gains certain traits?
Yes, actually, it's actually for the historical reason. And as a small talker, this is a little bit embarrassing part. But we don't have we have a separate way to write the global thing like this. But of course, but you can change it. So yes, in short answer, yes, there is basically more like a user customizable global actions or the non-user customizable global actions. But programmer, application developer can change it, and you can say what should happen when somebody joins and what kind of behaviors an avatar gets when somebody joins and stuff.
Yoshiki, I don't know if you've seen, there are a couple of, maybe I missed the answer, there are a couple of questions in the chat. So how are sessions kept alive and what's the main market?
Session kept alive. So each browser tab like has the WebSocket connection to one reflector and the reflector as long as basically they are in the same session, and as long as this session or any remaining connection is there, the reflector keeps sending some stuff to the participants. If that answers.
So let's say the reflector keeps going, but all the clients close down for some reason, and then they all come back. How would they go back to seeing the same thing?
Oh, so the reflector, when the last client leaves and I think the 30 seconds passes, reflector knows that the latest snapshot and remaining events, right? Basically, it creates a file with those two things, and then store it on the server. So tomorrow, you come back to this room as a first user, and the reflector looks up what session it was, looks up that latest snapshot and remaining events, and instantiate like that session. So that's how it works.
Got it.
So, yeah, not much logic. The reflector location may be different tomorrow.
And the question about the market I thought was interesting as well. Are you hoping to make some money out of this?
Yeah, market. Which
Yeah.
so the way we are trying to make money is basically the messages and the reflector traffic. So if you, as an application developer, create useful application, and you get money from your customer, then we would get money from you because you use our reflector network. But also, that was one of the ideas, but nothing prevents us from making good applications. So still Microverse is rather a framework for people like you to make more stuff. But we could make, so we could make a different application. Like the green light was going to be one of those applications. We charge money, but we didn't. And by the way, you can use Greenlight for free, so right. And the marketplace, yeah, I mentioned NFT, and we didn't do that either. But if somebody makes up the object market, that's fine. Still, you use our network to exchange things. And yeah, I couldn't tell how far down I went. CRDT session, client, group of people, something in the session. Oh yeah, I answered this. Oh, main market, it's Marcus. Main market, Croquet IO is targeting. So I forgot to mention one thing. So another thing, based on the Microverse, it's a web showcase. So another thing you can do, what's going on with this? Web showcase, and yeah, please look up this. So if you have a WordPress site, you can get the WordPress plugin for your WordPress site. And what you can do, this is in Japanese, but you can embed showcase page. I'm gonna stop sharing my screen here. So this is another Croquet Microverse, but in this world, you don't have to write really any code. You just drag and drop the assets and say which one should go where, and you are done. You can create a world like this. So another thing we are trying is to make it more accessible by making this kind of stuff. And the Word Showcase, Web Showcase is right now still free, so you can have any other. But if you want to use this kind of stuff for business, yeah, we can talk. And so the Web Showcase is one of the ways of thing. And I should mention another thing we are trying. So my colleagues, our company is trying to make a Unity binding. So for game making industry, Unity framework is a big thing, and we are trying to provide a framework for Unity developers. And yeah, paying for a game is more common than paying for an application. So that may be a good thing. Model has to be the models. Yeah, model has to be. I'm answering the another question. Model. Logical part of the application has to be deterministic. Yes. So our physics engine, for example, is deterministic. Many other physics engines use random numbers in it, and that random number isn't replicated. But our random number generator is replicated, but also our physics engine does not use any random number. So yeah, it has to be deterministic. And third, yeah, thank you, third. Yeah, thank you. Autonomous headless client. Yeah, sure. Autonomous, depending on what you mean by autonomous. Yeah, sure. You can get data into the session. You can run a headless client on Node.js running on a cloud server. Oh yeah, Drupal. What does Drupal do?
It's like a CMS. It's like WordPress.
Oh, I see. It's a question for the WordPress plan. Not yet. But actually, yeah, you don't have to have. So I said Web Showcase and its WordPress plugin. You can use basically Web Showcase, and if you have good control on that Drupal site, you can embed Web Showcase into it. No, it's no problem. And yeah, so any more questions? And stop presenting.
Okay, I'll try.
By the way, if you double click the graph paper background, you can see the sort of the interesting.
Okay, I
how
want to
you
try.
can mess things up.
I have another question. I'm thinking a lot of Croquet, but I never got somehow a good idea what to do with it. So I was thinking, so what you showed us, or what I know from other demonstrations, is that there are always like physical or worldly objects, world settings. So I was thinking how to visualize, for example, okay, that's easy, class structure of Smalltalk, or how would a dictionary look like in 3D in a room, or how would a index tree or whatever structure be I don't know, visualized as an object. Do you know any work, or do you think yourself of how to do these things, or would that help, or would that be even interesting? Something like that.
Is that a question about visualization?
Well, to you or to anybody else, I mean, it's a very fascinating technology, and I think, yeah, your work is just awful, awesome, and yeah, I don't know. I always wanted to do something, but I don't know. For example, I like PDF, and I do these internal structures, but I have not. We always think in 2D, like how it looks on paper, how it looks on the screen. But in 3D, you have this 1 degree more freedom, which makes everything worthless, which we know. Like in 3D, the 2D layout is not interesting. 2D layout is completely difficult, but in 3D, you don't have this difficulty. You just put it there, and then you go around, so no problem. So this
it's an interesting question, and we, however, are looking at the entire thing through a flat glass display, which is 2D. So there may be something different waiting if it's actually 3D and in your physical world.
Yeah.
And at the same time, you know, people cannot fly, and most people don't have good 3D sense, especially if it goes vertical axis. And what's good? Yeah. So I guess the short answer is like I don't know, and there may be interesting things waiting. Also, yeah. So the another model update of the model with the updated model. What do you mean? The code? So I assume, Julie's question means the model code. So when code changes, it's an interesting problem actually. In some ways, you are in a different timeline unless the code is also data and synchronized. So if your code changes, then you need to do something. And what we offer is the persistent data. So you get to write, you as a developer get to write what's the essential data you want to carry over to the new timeline. And when the system detects that we are talking about everybody leave and coming back tomorrow. But what if tomorrow somebody has updated like the JavaScript code, not a touchable behavior, but application code. The system looks up and say, oh, the code versions are different. And then looks up the persistent data saved from the previous version. And you as an application developer loads the persistent data, populate the new session with it and keep going. So that's how it works. Scene inspector, A-frame. So Marcus, you can write one. So ChatGPT, conversation, and of course you could imagine to make objects and set the 3D terrain by just saying that's probably low-hanging fruit. And the actual conversation with multiple people. Even 3D or 2D, 1D, does anybody have a convincing example of multiple people with our agent and actually doing stuff? That's something I'd like to know. And time travelers, what's this? Oh, somebody answer. Visualization non-Euclidean. So the visualization is totally view side, or it depends. The model and view are separate. So then 3JS actually can help you to do non-Euclidean spaces. Delete something in the undo is something to implement, and we don't have an implementation of undo.
Hopefully it's okay. I deleted one of the boxes by mistake. I thought I was canceling out. But
that's fine. That's fine now because my talk is done. The snap actually, it doesn't have to be snap. I am sort of working on the blocks editing system in 3D. Snap is 2D, and I want to have blocks in 3D. So that may come at one point. Well, you can watch the YouTube. So one of the things.
One of them I deleted by mistake.
So here I'm taking everybody here, only 9 people, but so if you click on the play button, and I can scrub the timeline. So I'm showing going to skip forward to the Croquet part. So if you So the drag the YouTube tool from the left toolbar, instantiate, and you put the YouTube link in that app that becomes the shared co-watching application. Yeah, again, you don't have to, you can go to Croquet.io Greenlight and sign up, and then you can have your own world. And you better use it because the Greenlight is not the main thing we are pushing, and if people don't use it, it may disappear. And the times are available independent. Yeah, so the Croquet, yeah, exactly. The Croquet OS here, this is totally the logical thing. The fundamental part, that's the Vanessa's great design. The fundamental model part is separate from any view. The lowest level here is totally logical things only. What is, I mean, I don't know. Yeah, I don't want to, Marcus, we can talk at a different time. Yeah. Any more questions?
This is awesome. It's so nice to see all of this stuff all over again. It's really cool.
Well, yeah, because yeah, I was involved in the Squeak version of Croquet a little bit, not much. But yeah, besides the language is a little bit inferior here, but everything else works much better, I have to say, here. So, and we can have different languages if you want.
Yeah.
Yeah, so interestingly, we have a colleague who was at Meta, and yeah, he has many things to say about how Meta is trying to do and couldn't do. Mm-hmm. Yeah, Apple Group, yeah, so interestingly. Yeah, we will find out what Apple will announce. And yeah, what I should do is to check the flight status actually. So yeah, for those still here, and everyone was mentioning it a little bit, but there is an event tonight in California time. And I think you can watch it remotely too.
Well, I think everyone's saying thank you. I just wanted to thank you as well for taking the time to present this to us. Yeah, it has been recorded, so hopefully if you're watching this in the future, you enjoyed it as much as we have seeing it live. But thanks again, Yoshiki.
Yeah, thank you. Thank you very much.
Thank you, Yoshiki. I'll see you later. This is Evelyn Van Orden.
Yeah, thank you. Bye.
It was nice to get a little bit of history as well. That was nice. So just sort of seeing some of the old stuff, some of it from like when I was born, but to kind of fast forward into the future, that's amazing.
Mm-hmm. Yeah, so the ideas and implementations are two separate things.
Yeah.
And so I am 51, and I'm trying to stay young, but I'm failing. All the things have great virtue that in some ways ideas are distilled because that's the only thing they could do. But it's easier to see what was the idea in there. And if you look at the new ideas, of course, and new technology and stuff, you can do more stuff. Sort of the general idea.
Yeah, it's true. There's lots of room for improvement, isn't there? But take some of the old ideas and try and get inspiration from them, I think.
Mm-hmm. So 1:30. Yeah, I can stick around for like 15 minutes or so. But
Thank you, Yoshiki. I'm going to head off. I'm going to have a beer. And thank you, Tim, for doing the organizing. And I'll see you all next time.
Yeah, thanks, Bruce. I don't know if anyone else is hanging around for a bit. I can hang around for a few more minutes as well. And
Bye, Yoshiki. See you later. Evelyn. Bye-bye. I'm leaving.
bye.
bye-bye. Yeah, if we go to the Croquet.io site, I saw that there was like sort of a getting started, so you can sign up and get going, I guess. Is that the idea? I guess Yoshiki's gone, maybe.
Yep. So yeah. So the.
Oh, you're there.
And also, yeah, I'm still here. So yeah, Croquet.io. How does it look now? Croquet.io docs, DOCS. That's probably where I would suggest you to go. But also Croquet.io Greenlight is an application sort of separate from your like SDK. And the Microverse is an open source, so you can go to you can find a link.
Right. Microverse, right? Okay. Yeah, maybe the idea is to just try and write a few samples or something, see if we can get a little bit of inspiration. I think, like you, Christian, it's like, oh, how to get started? What could you do to just sort of get hooked into that way of thinking or doing things? I think that's
for example, the music box example is also available. And what did I say? It's like 400 lines with a pretty sophisticated view side update and stuff. So your first application can be like 50 lines or like 100 lines, and just maybe move a few things together or something. That's probably worth trying first.
Yeah, I think it's just getting used to some of the concepts and playing around with it a little bit to get a feel for what's possible.
Oh yeah, and somebody instantiated the painting too. So yeah, another thing. So still 6 people are still here. Another thing you can do. So I created the painting too from the left, and you can do something like this, and we can draw together. So there's a separate app for it, but you can do stuff like this also. Okay. So the green light.
Were you showing something on your screen? Because you're not sharing your screen. I don't know if you showed something.
Oh, well, yeah, I'm showing it in green light.
Oh, sorry, yeah.
No, I can do it.
Still on. Oh, I see. Yeah, okay.
That's the one. Oh, this is the entire window. Yeah. Yeah, this is, so the green light was conceived as a place where you create stuff and combine them.
Right, yeah.
And it's actually 10,000 lines of code, give or take. And I wrote most of it. And you can write 10,000 line application, so you can do quite a lot.
Cool.
And Microverse is like 15,000 lines. Oh, I wrote most of it, so yeah.
And what tooling are you using for writing the code? Are you just doing a text editor? Or are you using?
Yeah, Emacs most of the time.
Emacs.
Sometimes
right, okay.
I do use VS Code. I don't. Yeah, I don't. I try not to die with Emacs. When it's easy, I use it.
Right. Unfortunately, Smalltalk has spoiled me. I just like finding the references and jumping around and just organizing things in such a way. It's just sort of, next thing you know, you've written a few tools and then you're stuck. You're sucked in, aren't you? I think it's trying to create that same environment in something like Microverse, where you kind of got this feeling of familiarity and you know, you're creating tools that help you in the world. But I mean, it looks like it kind of starts to get there. I mean, presumably that bar on the side, is that something you can add to the like where you're creating those things? Can you attach like snippets or something to try and customize the world? Is that the kind of feeling?
Sorry, I missed it.
I said, like in like green light, can you attach things to that side menu? Like sort of trying to like create snippets and like, you know, sort of customize your own tools in a way to try and.
Yeah, you know, wrong reasons. Yeah, definitely that should be the case. We should be able to do. And by the green light is open source too. You can modify that.
Oh, okay. Oh, okay.
Yeah, you can have your own installation.
Interesting, interesting. So many cogs going around in my brain. It's just having the time to do all of these things. That's the problem.
Mm-hmm.
You need to replicate yourself sometimes.
Yeah.